Matt, I gotta say something. It's been too long since you've been on the road to autonomy, and we're super excited to have you back and talk all about the wonderful things that you and the team are doing at Parallel Systems. To recap, since we last talked, you've raised a total of nearly $100 million, and you got approval from the Federal Railroad Administration to test autonomous trains on tracks. Well done, sir. Well done. You've accomplished a lot.
Thank you, Grayson. It has been too long, and I'm very excited to be back here. So, lots to talk about. Let me recap for everyone who's listening in who we are, what we're doing, and where we're at. I'm excited to talk with you today about that. Parallel Systems is a builder of autonomous vehicles that use existing rail infrastructure. We're doing this because autonomous rail is able to improve service quality for customers. And we want to move more things by rail because it's very energy efficient. We can carry very heavy freight, and it's cheaper than trucking. So this is very relevant to this time we're in right now, where transportation costs seem to be going up endlessly. We are testing and operating our Gen 2 vehicles in Georgia. We are the only company with this type of technology that has federal approval to be on the general rail system to operate this. We're in Georgia, outside the port of Savannah, and we're very excited to be starting production of our third gen vehicles right now.
And it's not just testing. You have the legal authorization to operate on 160 miles of track. How did you score that?
Very patiently. So one of the challenges that we encountered was that rail is one of the oldest modes of transportation, and so it has some of the oldest regulations, and these regulations are what we call prescriptive. They don't talk about necessarily the safety outcomes. They prescribe the technologies that should be in place to make sure things are safe. And what we're building doesn't necessarily fit very well into that. And through a lot of relationship building, trust building, understanding, is we came up with a way to introduce this technology alongside existing rail. We're focused on a performance-based approach to safety, which is looking at the safety outcomes and being a bit more agnostic on exactly how you're doing that. And this is a framework that allows us to not just operate this vehicle, but could be beneficial to many other technologies in rail.
I know we talked about this last time, but that was a while ago, so I want to refresh my memory and the audience's memory. How does your system interact with the traditional rail? Who knows the right of way? How does all that work?
So one of the advantages of rail when you're talking about AV deployment is that it is centrally managed. Think of it as like air traffic control, where the entire network is centrally controlled from a back office. And our technology is fully compatible for what I'll call all the rules of the rail. And we behave the same way a normal train would, in that we are getting that track authority that's unique to us, and that we're respecting those physical boundaries of what track authority is unique to us. We're never randomly encountering another freight train through that coordination. So that's a big advantage, in that our perception system then operates within that track authority. We're evaluating, is it safe to proceed? We don't have to judge the actions of other random agents on that network. So part of our tech stack is that we integrate into this back office with our software. We have software in our vehicle, but we have back-end software that does the motion planning, does the abstraction, does the integration of their train control and other business systems, so that we work alongside these railroads. So a dispatcher who's today dispatching and monitoring the network for traffic and making sure that everything is flowing seamlessly, we would appear as if we're just another train on the same network. That's a little bit shorter, but behaves the same way.
And how is the traditional rail industry accepting your autonomous system?
There's been a tremendous amount of enthusiasm around this, because we are solving a real barrier for them, which is that there's really been little to no revenue, top line revenue growth for the industry. They're very, very good operators, very, very good margins, but no revenue growth, because they serve freight lanes that are long distance and high volume, and they've really done exceptionally well there. But the majority of the freight that moves in this country and worldwide is a lot shorter than that, and it's lower density than that. And our technology solves for the service quality issues and the cost of getting things on off the network that limit their ability to go after these new markets. So that's obviously very, very exciting for them, who are now looking at, like, how do we grow? Like, we're we've already really matured and developed this system and service using the tools we have now. Parallel is bringing a different set of tools that can work alongside these, but very importantly, allow them to grow and offer services that are still going to beat the price of trucking for their customers.
And I want to highlight something else we think is important, the community aspect. If you look at the quarterly inland port in Georgia, for all practical purposes, it was mostly abandoned until your system came along because of it's too short of a run there for trucks, and a lot of trains didn't go there. So what reaction are you getting from the community as you're revitalizing a local inland port?
Yeah, we've done community outreach with G&W ahead of starting this initial Georgia pilot, and I would characterize this as very, very positive. And what was interesting when we did that community outreach was that when you started near the port, the reaction was different from the response we got when we were further from the port in the western part of Georgia. So when we're close to the port, a lot of those communities are enjoying the economic success of the Port of Savannah, but there's a lot of truck congestion that has been a result of that. And so first responders, community leaders don't want to see the economic activity go away, but they would very much like to see less truck activity that's causing accidents, causing congestion in their community. When we went further west, the excitement there was this is a new transportation link that could position our community to actually capture jobs and new businesses, because we don't have a great highway access to the port the same way like Macon does, for example. So it's very interesting to do that outreach and see the variations in perspectives in terms of what a technology like this would mean for that community.
And if you look at it from the community perspective, your technology, you said it, I'll reemphasize it, will create jobs because you have individuals that work in those warehouses and work in those logistics environments. You're going to create jobs, and to me, what you're building is an economic stimulator.
Yes, it's a job creator for the rail industry. Very importantly, our position is to work alongside existing freight trains, and the jobs we're creating are not necessarily one-to-one with rail jobs. There's no one on board, but there is equipment to inspect and maintain. There's track to inspect and maintain when you're putting more freight ton miles on it. And one of the new jobs that is being created around this technology is we have back office supervision. So we encounter something that requires the vehicle to stop. It detects a potential hazard. It detects that a wheel bearing, for example, is overheating. The vehicle will stop, and it'll ask someone in a remote office to assess that situation using the data and telemetry we provide. As we drive more freight to rail, we have people who are staffing forklifts and loading containers in and out of the system. But it's also a job creator for the community. We've had a lot of interest in where we're deploying our vehicles and technology. Is why not do manufacturing there? We manufacture some of the components and subsystems locally, but this is fairly heavy stuff. So it's kind of an easier decision to say, we'll just drop ship all those parts to that area and we'll put it together there locally with local workforce. And any successful economy, I think, is a foundational ingredient. It has safe, low cost, reliable transportation. And so when you're furthering that for a community, you're going to have other economic activity, right? You're going to attract new businesses, right? Because hey, if we produce these goods here, we know with Parallel we're going to have the lowest cost, most reliable access to the port, so we can export that.
Then when you take the manufacturing, politicians love manufacturing jobs, by the way. They're sticky jobs. Then you have the repair engineers that fix it, then the maintaining engineers. You create all of those jobs, and on the manufacturing, so. You're based out in California. You have operations in Georgia. Could we potentially see a scenario where you have a manufacturing facility in the Southwest, a manufacturing facility in the Southeast, and perhaps the Northeast and the Northwest, depending on how you grow this system, just because the cost of shipping it, frankly?
Yeah, no, totally. I mean, we are looking at that very same model, and it's not new, right? I think if you look at the heavy construction equipment industry, they follow that model too. It's Caterpillar has various manufacturing and equipment distribution facilities all over the world, not just in the U.S. And I suspect some of their thinking is for the same reasons that we think about that way, is because this stuff is heavy, and so you need to be thoughtful about where you are doing end manufacturing, because some of their stuff is a lot heavier than ours, but shipping heavy stuff can get very expensive. We are actively To date. We have done manufacturing here in California. We have a contract manufacturing partner. I will say that we're also working with a contract manufacturer now that we're ramping up in Michigan. I'll be able to tell you more probably in the future. And we are also in conversations for doing some of that internationally too right now.
So you open the door, I'm going through the door. We could potentially see a parallel international expansion down the line?
Yes. Yes. And I'll be back to tell you more about it, Grayson, when as soon as I can.
Okay, good. But you can't let 3 years go by. That's the rule now. No, none of this 3-year nonsense.
No, I promise. I'll put it on my calendar. Not happening again.
Awesome. So international's on the horizon. Contract manufacturing is ramping up. And unfortunately, inflation's going up, which is not a good thing. The price of diesel is going up. When you look at the economic headwinds that we're facing to move a traditional freight over the road, is that increasing the inbound to parallel?
Yeah. The last few months have been very interesting for us. Our position has always been we're going to lead with giving shippers what they want, which is they want to save money. They want the service quality, which is about daily, regular, consistent service. Those are the fundamental things they need. They really don't care about how you do that. As long as you're doing those things, like that's how they can build their business around that. What we're seeing though is besides like I want to save money, what is incredibly stressful right now for a lot of these shippers is that their transportation budgets were set back in December before there was a conflict in the Middle East, which is now, of course, consequentially causing diesel prices to grow exponentially. Trucking and rail passes those diesel surcharges down to those shippers, and now they're past their budget. They're spending beyond the rate of their budget, and that's an incredibly difficult situation for them. So what they really like about us, besides we're going to save you money, is that because we're electrically powered, we offer a lot of pricing stability. Rail is so energy efficient, and when you couple that to certain regions in the U.S., like it's practically free in terms of energy to move freight on our platform. Georgia, for example, go back to them, like they have an electric rail schedule where it's $0.00 per kilowatt hour at certain times of night. So very hard to beat a rate like that.
Can't beat a rate like that. Is that what's led to the 300 vehicle backlog that you're currently sitting on?
That represents demand here in the U.S. as well as international opportunities. So we're very excited to be starting production of our 3rd gen vehicle now to start executing on some of those.
What's changed? Last time you were on, we talked about the Gen 2 vehicle. What's, from a technical standpoint, what's changed from the Gen 2 vehicle to the Gen 3 vehicle?
So this was always our roadmap, is that the Gen 2 vehicle was a product market fit discovery. So it's a track-worthy prototype, highly instrumented, build it fast, MVP. We made trade-offs intentionally on the powertrain to get it out there and get the operational practice under our belts as well as for the customers. So I would describe the Gen 3 as it's much more performative, it's much lower cost. And so we put a lot of effort into that. The powertrain it will be able to move 160,000 pounds of freight, where our current vehicle moves about 60,000 pounds of freight. And we'll be able to move that faster at steeper grades too. So we'll be able to do over 60 miles an hour with that type of payload. And we have done a lot of engineering on powertrain, chassis, like all the major cost drivers. I'm very excited about what the team has developed. We have even innovation in the chassis. We often get questions like, well, would you retrofit a rail car? It's like, yes, we could do that, but you will pay a lot more because the most expensive part of a technology like this is the powertrain. Now, we have a big advantage over trucks is because our battery doesn't need to be as big, it's smaller. There's less torque and work required because you've got low rolling resistance. But still, like, you have to put a lot of thought into that. The powertrain is what should be leading the architecture rather than the chassis leads the architecture. Like that's what an OEM for automotive does, right? It's like they incorporate a lot of tier 1 parts off the shelf, but they're integrators. They have a custom car body chassis. It serves the passenger, it serves the powertrain, and then the wiring and software kind of ties it all together. And like that's been our philosophy. So we have innovated on the chassis, and it's really cool. We're taking a giant piece of steel plate and we're plasma cutting it and we're working with fabricators that would normally build like sections for bridges, and we put it in a brake and we're bending a lot of the steel. So it's like a giant piece of origami to get that stiffness, but also get like packaging features, because secondary structure like brackets, et cetera, as you like try to like glue on all this stuff can be a big cost center, not just because of the parts, but because of the labor that goes into it. So we're designing the chassis to serve the integrated vehicle, integrate the powertrain, all the other parts, thermal management system, battery management system. And what we are really proud of is that it's dramatically less than what would be conventional steel welding, because there's just not a lot of weld content in it compared to like a normal rail car.
So you're really focused on the engineering. Does that come from your background at SpaceX that made you so focused on the engineering aspect of this?
It's not me personally. I wish I was like more in the maybe not driver's seat, but co-pilot seat. I would say it's just in our company's DNA. It's like we are technologists at our core, and we are very, very curious about understanding the real problems to solve. Like that's what's led the architecture of vehicle is like rail needs better service to compete for more freight. We need to reduce the cost of getting stuff on and off the network, and that's what drove the architecture we have. And now we're on the next chapter of okay, we have a product that's been well tested and vetted against customer needs. Now, how do we make it perform better and be less expensive? And so the team has aerospace, automotive experience. We have people from the rail industry on the operations side. It's been a great fusion of like different backgrounds, but like we're out there relentlessly optimizing for how do we have a very safe, reliable platform that is very, very conscious of like how much it costs. And I'll add too that this is another advantage of rail for AV deployment is that it is a simpler design domain. So you don't need as many distinct sensors to observe this environment, which again, I'll remind you is like secondary to that train control, which is a deterministic integration that we have, that we're getting that unique authority.
And the other thing is, from a freight perspective, your system can haul a lot more freight than a truck. Another thing is you're not subject to hours of service. I mean, if you look at your traditional class one, they can go on for miles. How long they can, I'm curious. So the Gen 2 went 25 miles an hour. The Gen 3 can go 60. How does that change the dynamics of the platooning system that you've built with the couplers?
It's all the same model, and we've done a tremendous amount of work validating that model of the dynamics and how we control. We've done testing with a Gen 2 up to 40 miles an hour in Colorado, and that's been incredibly useful for us to actually verify and validate the dynamic performance and braking in really the gold standard for rail. Even Japan sends equipment to Colorado to test there. But all those learnings, the software, the electronics architecture, a lot of that carries over. A lot of the cost down has been about upping the powertrain, reducing the chassis cost. But we're carrying over a lot of those learnings. And the modeling we've done has been well verified and validated with the testing we've done at scale here with up to 3 cars in a platoon. So a very good anchoring in that.
Last time you were on, you were so excited. I think it was a week or two. You were going to Colorado to test the Gen 2, and I forget the name of the facility, but you were so proud to be able to go there and test. Will history repeat itself? Will the Gen 3 be going there next to be tested?
Yes, I won't tell you when, but we will be there soon with Gen 3, and there will be platooning testing happening there too. And we'll see how fast we can go.
What is it about the facility in Colorado that makes it so world renowned where rail companies go there to test?
I'd say there's a few things. I mean, number one, there's world-class support around maintaining that infrastructure and running the test campaigns. It's not just there's a bunch of track out there. There's skilled people in instrumenting equipment, conducting experience tests to verify industry standards, regulations, and that that the talent tied up in that personnel is like probably the most valuable. But the facility is very unique too. Is that you have a very, very open space with various track types. You have a high-speed loop. You have a perturbation track. You go to like these automotive testing grounds, right? And they have like the cobblestones and stuff. It's kind of like the cobblestone track of railroading. But you get to excite like different dynamic responses with that. And so that's a unique set of infrastructure that I'm not aware of like really being reproduced anywhere else in the world. But they've been great partners along this journey to help us with testing and in modeling as well.
When you're out there, do you test different sensors arrays, different layouts to perfect the system?
No, a lot of the sensor testing happens first here in this building, and then we have our own private test facility about an hour north of Los Angeles, where we do our initial real world testing. We'll put these sensors through environmental chambers too, like temperature cycling, but we get out in the real world in our own private test track, and there's plenty to learn in that environment. And then what we're doing in Georgia right now is those sensors are in ride along mode and they're observing as well. And we've worked with certain customers to put our sensor package on the front of their locomotives too, so that we're out there in the real world collecting data to help us with training.
What are some of the biggest obstacles or hurdles that your system has to overcome? Because if you look at rail, you have rocks, you have dust, in some cases, you have snow, you have sleet, you have various different environmental weather conditions. What are some of the biggest hurdles that you had to engineer your sensor kits to come over?
I'd say broadly, it's about making sure the sensor kit robustly works over a variety of lighting and weather conditions. There's a roadmap for evolving the feature size at which we detect. It is a little bit of a unique thing with rail, is that sometimes you get like weeds and things like that, or like little rocks. Like you don't slow down for that stuff. But we're very focused on looking at identifying people, large objects that would be a derailment risk, cars, buses, trucks, whatever that might be stopped at a grade crossing. Those are very meaningful safety improvements for rail environment, as well as tracking, here's an object in motion over here, and propagating what its path of motion is likely to be, and whether or not that intersects with our path of motion.
You're putting all the pieces together to scale commercial operations. When you do scale commercial operations, will it be with a Gen 3?
That's a really good question. I'll say that Gen 3 is definitely going to be fielded for commercial operations. There are some things we're looking at right now for commercial operation of Gen 2, but I'll have to come back on your show to share the details of that. And I think it would be a pretty cool announcement too, once we get everything buttoned up, because I'll go back to your questions on the shippers. Like, this is a meaningful solution for them. A lot of shippers, transportation is a major cost center for them, and even saving 10-20% hugely impacts their bottom line. So this is very compelling for them, and a lot of them, there's a lot of interest in being part of what we're doing in Georgia right now, even if we may not be moving freight for them commercially. But it's about verifying business system integration. Like, we have your freight, right? Like, where is it? Knowledge of where the freight is, visibility is a huge opportunity as well. And we have robust localization knowledge 30 times a second. And so as you integrate through these transportation management systems, the business systems to the customers, providing that visibility is a big unlock for them too. Imagine the time savings of knowing, okay, my freight is over here and it's going to arrive at my pickup location in 2 hours. I can then get my drayage driver ready to come meet that load there, and I'm not wasting time to do that.
I'll say this. When you're ready to announce your commercialization, wherever it may be, how about you and I go there in person, and we'll record it in person, and we could see the operations in person and record on the spot?
I like that idea. Yes.
I like that. So we're going to table that, and I'm not going to push you on that, because at some point we'll have the commercialization. But if you look at just markets as a whole for opportunities, obviously your traditional class 1 rail historically loses money under 500 miles. So to me, it's like, okay, that's an opportunity. You have your short line railroads. Okay, that's potential opportunity. And then you have your drayage. I'm like, okay, potential opportunity. Am I thinking about these markets the correct way?
Yeah. No, you were absolutely thinking about the right way. This is about equipping railroads to do services that are really not an option for them today. Their competition today is trucks, and so they have to compete on service. They have to compete on price. And that has sometimes been a challenge for rail to do over shorter haul lanes or lower density lanes too. Density does matter for rail, and it's not, we're not taking it to 0 or 1 unit of freight, but a railroad, for example, would normally think of a very attractive freight lane as I'm doing 500,000 revenue moves a year. Like that's the density threshold they're typically looking for. And you can think about parallels taking that threshold down like an order of magnitude or more. It's like 50,000 revenue moves a year or 10,000 revenue moves a year. And so that opens up a lot more new markets for them. But this isn't just for short lines. It's not just for class ones. It's about railroad operators who are in a position to serve shippers who do containerized freight. In the future, we'll be able to do trailers. It's not a version of the vehicle that we are building right now, but it's a very obvious next step for us is to stretch the vehicle and do 53-foot containers or be able to do trailers. And we'll be able to bring those a lot closer to shippers and customers, reduce the cost of getting on and off the network, but very importantly, give them all the service they need, which is at least like once a day. And that's what we hear so many shippers say is I would give more business to rail if they could meet my service expectations. But often the density is not there for rail to meet their service needs.
You're creating an interesting opportunity in the market. And okay, so you look at that further on the parallel site, you have a map there showing the LA to Phoenix. That gets interesting on a route like that. How many parallel vehicles do you imagine running in one of the platoons? And we talked about this 3 years ago. Can the vehicle still break apart in an intersection?
Yeah. Yes, absolutely. I mean, I should remind your audience that we don't have couplers. They're bumpers, and our software at the back end orchestrates all these movements. And so we move together in platoons, and those bumpers are in compression. But because we can control the tractive effort of every single vehicle, we can arbitrarily make or break. This is why, like, I think about what we're building is like the internet of freight. I can route packets. I can break apart packets on the network, keep grade crossings open. Rail very much likes to operate what they call unit trains, where you've got a bunch of freight originating at point A, a bunch of freight going to that same freight going to point B, and that's what they do. We can do more like carload of intermodal, where we could originate a port with a platoon of vehicles up to 50. That's what we look at as the upper design envelope. Service design tends to like cluster around like 10 to 20, maybe 30. But those 50 vehicles in platoon could originate from the port, and then on the network, 10 break out and go to Phoenix, 20 go to Vegas, and the remainder go to like Fresno, for example. And so that's a very unique capability that is consistent with the service improvement that is really essential ingredient for rail to actually serve more of these shippers.
You unlock efficiency. You said the internet of freight. The first thing that goes to my mind to be a technologist is Cloudflare. You're basically having these secure pipes and the ability to increase efficiency, lower latency. I mean, this becomes very, very interesting. The model that you described, you easily could go all over all 50 states, but then you run into class ones. Will they integrate with you? How are they going to play with you?
We have a capability to integrate with any railroad. We do dark territory, we can do CTC, we can do PTC, which is a safety overlay. So there's nothing about how a class one operates that prohibits us from integrating into it.
Oh, and that's the same thing, which brings to a great line that you said in the LA Times. You said Parallel Systems is building the Waymo of freight. Waymo integrates into cities anywhere. Parallel Freight's integrating to rail anyway. I like that line that you said. Parallel Systems is the Waymo of freight. I like that.
Yeah, we're not carrying passengers, of course, but just to make it relatable to people, we are very dynamic, very flexible in terms of how we route our platform to go pick up or drop off freight. And you can think of it as like the last mile delivery service using existing rail network.
At the end of the day, who's the customer for you? Is it the short lines? Is it the shippers? Who at the end of the day is Parallel's core customer?
So our customers are the railroads, because we're a technology vendor for them to then go market and operate these new services using our technology for their customers, which are the shippers. Now, we do maintain a number of relationships with shippers who very much want to save money on transportation, very much would like to delegate more to rail because it alleviates them from finding a driver for every single load. They like the cost savings, but rail doesn't have the service. So those shippers have been in many ways like informal partners to us, like joining us in meetings with the railroads. So I think in many ways, like they're one of my customers, But in terms of like the actual agreements and everything, it's with the railroads here in the U.S.
You hedged. I like that. In the U.S., even though earlier you said international. So you're sitting down with the railroads. What's the pitch? How do you get them to sign the dotted line? What's that pitch?
This is an enterprise sales process. I think in the past we often found ourselves like shepherded towards innovation team or technology team. We are doing this because of the commercial revenue opportunity for the railroads. They're very financially driven, and so I think our best executive sponsors are really anyone who has a responsibility for growing revenue, anyone who has responsibility for efficiently deploying capital. And really the technology and innovation should follow that. Like technology should be there to enable the business. So that's what we found is very effective as a sales process with them is identifying here is where you have a track that has available capacity. You've got a shipper over here spending way too much on trucking. Here's how this would work. Here's the service. Here's the financial pro forma. And you can see the returns on capital they would get, not just by buying our equipment, but like anticipating like all their OpEx and CapEx. And besides new revenue, like that box is checked, is like, okay, these are very, very attractive financial metrics for us. Many of these class ones like they are very capital intense, but they have a lot of cash that they don't really know what to do with. And so we become a growth opportunity for them that allows them to continue on with the margins that they've become used to. So that's what's worked for us. And now we're very excited to be actioning that interest.
I think it's interesting because you're giving the rail industry tools to grow. I mean, historically, it's not a fast growing industry. It's a massive free cash flow industry, but it's not a growth industry. And you're giving the industry tools to grow and to take trucks off the road. And you're modeling or they're modeling, are they seeing that opportunity to remove X amount of trucks and what that would do to their bottom line if they were to put it onto the rail?
Yeah, I mean that's part of what we share with them is here's the lane, here's the opportunity, here's the shipper, here's the revenue that you would make by actioning this, and let's account for all the OpEx, and that includes like not just like operating our technology, but like hey, you have more employees that are like now stuffing boxes into this. They're overseeing this operation. And all that's accounted for. And that's what we found to be very powerful with them is that we're going to make you're going to get a good return on this CapEx that you're going to deploy.
Summarize it this way. You're building the future of rail of parallel systems. In your opinion, Matt, what is the future of parallel systems?
I mean, it's really about executing on these commercial deployments. Our mission is going to be measured in how much we can grow the rail industry, how much more freight we can move by rail, and realize that with a lower cost of goods movement. I think we have more discovery to do on how much we can actually truly save. You and I didn't touch on it, I think, enough today, but we have a lot of heavy freight capacity. We've only recently started really engaged with people active in the beverage industry. And moving beverages is very heavy. And those truckloads are not getting cubed out. And so when we have a platform that can carry 160,000 pounds of payload, basically 2 full semi trucks, that's highly interesting to someone who moves heavy stuff. So you can think about like you can consolidate 2 truckloads into one. Now you're talking major savings. But that's what I see as success for us is like how we enable railroads to capture some of this business. We decongest highways. A lot of, I experience it. People who know what we're doing see it around ports, like all the truck congestion. Trucks are not going anywhere, but there's a lot of market share that should be directed to rail as a public benefit. Not just on goods cost reduction, but decongesting these highways.
160,000 pounds is a lot of beer, and I say that because the World Cup's coming up, and I'm not saying this, but the data's out there. The individuals that go to the World Cup tend to drink a lot. They should be running the beer on parallel systems because they need a lot of it.
I totally agree. We could put like some beer taps on the side of the container and it's like a pop-up Bar.
Listen, you're in LA. Mr. Crunky, sir, if you're listening, figure out to put the parallel system in the parking lot and have a pop-up. There you go. That's my pitch. Put the parallel system in the parking lot at the World Cup, because what parallel system wants to do, they want to grow the rail industry, and a growing, healthy rail industry in the U.S. is good for the U.S. economy. The future is bright. The future is autonomous. The future is parallel systems. Matt, thanks so much for coming back on the road to autonomy your third time. And for your fourth time, I can't wait to do it in person when you make your big commercial announcement.
We're going to do it. We're going to do it on site.
Billions and soon trillions in value will be created in the autonomy economy. By the time a trend becomes consensus, the alpha is already gone. The gap between uncovering signals and reading headlines is widening fast. When it's a headline, it's no longer a signal. Enter Autonomy AI. We decode signals before they move markets, giving you conviction in the autonomy economy. Autonomy AI. Your models, our intelligence. Visit AUTNMY.ai.